Translate these sentences and solve. A number subtracted from 20 is equal to 3 times the number. Find the number. So when we're trying to translate sentences into math equations, we need to make sure that we write what we read as we read it. So the first thing is we have a number. We're going to need to use a variable to represent that. Let's use n. Then we have subtracted from 20. That subtracted from is a phrase that has to be written in a sense backwards. That we have this number, we want to take it from the 20. So we're going to start with 20, and then we're going to subtract the n. The word is equal to is our equal sign, and then we have 3, which is a number, times, which indicates multiplication, the number. That's very important because the number means that you've already chosen a number and you have to continue using that number. Now we want to try and solve this problem. Since n is on both sides of the equation, we need to get the variable all together on one side of the equation. So we can add n to both sides. 20 equals 4n. But we still need to get n alone. 4 is being multiplied to the n, so I will multiply both sides of the equation by the reciprocal. When we simplify this result, we get that n is equal to 5. But in a word problem, we need to actually answer in words. The number is 5. Here's another problem. Find the number such that negative 64 is 12 more than 4 times the number. So find the number was the last sentence in the last problem. And now that's just setting up what it is that we need to do. The such that is describing what the situation is. We're going to start with negative 64. Is our equal sign. 12 is a number. More than is addition. And since addition has the commutative property, we can write addition either in the front or the back. And we have 4 times, again that's a product, and we have the number. So we're going to try and solve for n. We're going to get rid of the furthest thing first. Since 12 is added, we'll add the opposite. We get negative 76 is equal to 4n. To get n alone, since 4 is multiplied to, we multiply by the reciprocal on both sides, and we get that n is equal to negative 19. Again, we want to answer the question. The number is negative 19. Here's one more example. If 6 is added to the quotient of a number and 3, the result is 1. Find the number. So you always want to read through a word problem completely and make sure you identify everything in it and that you know what it means. If 6 is added, well, we pretty much know that added means we're going to use the addition symbol. To the quotient. What in the world is a quotient? A quotient is the answer from division. So I'm going to have to divide these two numbers and get that answer. So we'll start by writing 6 is added. This is not an equal sign because it's indicating the verb added. Is added, so we're going to do addition. The quotient is, as I said, division. N on top, that's our number, and 3 in the denominator. The result is, now that is our equal sign, 1. So we're going to try and solve for n. As you can see, there's a fraction in this problem, and we've learned recently that in order to solve equations that have fractions, we can clear the fraction first by multiplying every term in the equation by the LCM. The LCM for this problem is 3. So if I multiply each term in this equation by 3, we get 18 plus n equals 3. We're multiplying by that LCM so that we can clear out the fraction. So make sure you do reducing and you can see what's left. So one more step in trying to solve this equation, getting n alone. We need to get rid of this 18. It's being added, so we add the opposite. We add a negative 18 to both sides of the equation. We get that the n is equal to negative 15. But again, this is a word problem, so we want to answer in words. The number is negative 15.